Hi guys, the topic for this video is Pythagoras part 4, problem solving. Okay, so you must so far know how to work out Pythagoras, how to use the rule to work out the longest side, okay, and how to use the Pythagoras rule to work out the shorter sides, and also how to use Pythagoras to prove whether a triangle is actually a right angle triangle. So Pythagoras part 1 was learning how to use the Pythagoras rule to prove whether a triangle is actually a right angle triangle. Then Pythagoras 2, we looked at how to work out the longest side. We call the longest side hypotenuse. So how do we work out the hypotenuse using the Pythagoras rule? And then Pythagoras 3, you learn how to find the shorter sides of the right angle triangle using the Pythagoras rule. Now for this video, Pythagoras part 4, you'll be learning how to be doing problem solving from worded problems, okay? So sometimes they may not give you a triangle, they expect you to read a worded problem and for you to kind of draw a diagram yourself and then solve to work out the missing side. So let's look at this example here. From home to school, Nancy travels 6 kilometers south, then she takes a left and goes for another 8 kilometers. How far is her school directly from her house? Okay, so let's start from the origin. So Nancy travels 6 kilometers down. Okay, very good information. What else? And we're also told that she travels another 8 kilometers to the left. How far is her school directly from her house? So let's assume that she starts from the origin. We have a grid. Okay, you don't need to draw a grid. You can actually draw any sort of triangle, but I'm just using a grid to help us understand what's going on. So she starts from her house, Nancy. Then she travels 6 kilometers down. Okay. Then from there she turns left. Okay, so it's our right, but going to be her left for about another 8 kilometers. Okay, and that is the school. Does that make sense so far? So 6 kilometers down, then from there she turns left 8 kilometers. Doesn't matter if you do it the other way, it's absolutely fine. Then what happens is the question says, how far is her school directly from her house? So of course it's asking us to work out what that side is there. Does that make sense? Okay, if it's directly from a house, then we want to know, okay, the distance from the house of the school on a straight line, basically, okay, without making any turns left or right. So what is that rule there? We need to use the Pythagoras rule, but what sort of side are we working out? Is it the shorter sides or is it the longer side? Clearly, anytime you're working the diagonal side, that is the hypotenuse. Just a quick tip, okay? So we need to work out our longest side. So remember the rule to work out the longest side, okay? So we've got 6 kilometers, 8 kilometers are shorter sides. How do we work out the long side? So we just add up the squares and then square root them, okay? So let's call the unknown x. So we add up the squares of the shorter side. So 6 squared gives me 36 and 8 squared gives me 64. 36 plus 64 gives me 100. Then what do I do to work out what x is? Just square root of 100, which is 10 kilometers. That's all it is, okay? Whenever you're working out the longest side, just square the two shorter sides, and whatever you get, square root. Make sure you write down the units though as well. It is 10 kilometers, okay? Let's look at this example now, example 2. Let's read this out. Jason needs to find how high this window is. He leans a 15 feet ladder against the window. The distance from this house to the foot of the ladder is 3 feet. About how high is his window? So these two bits I've underlined are key information. It tells us the distances of the sides. So Jason, first of all, he leans a ladder against the window. So, and then it says the distance from his house to the foot of the ladder is 3 feet. So from the house to where Jason is about 3 feet. And from the house to the window, we don't know exactly what the length is, okay? But it's given us that he leans a 15 feet ladder against the window. So you can kind of tell if you use your imagination and common sense that the ladder against the window would have to it would be sort of it wouldn't be vertical, okay, straight up. The ladder would have to lean against the window, so it would kind of be diagonal, okay, and it's represented by that triangle over there. Okay, so what we need to do in this question, it says about how high is his window from his house. So we need to work out what that side is. So I'm going to ask you now, am I working out the one of the shorter sides, or am I working out the longer side? From the house to the window, that I'm working out the shorter sides, one of the shorter sides. So what do I do? Okay, let's call one of the shorter sides that we don't know, let's call it A. Let's call that B, let's call that C. We know our formula, A squared plus B squared is equal to C squared. Replace the B with 3 and replace the C with 15. 3 squared gives me 9 and 15 squared gives me 225. If you don't know what 15 squared is, you can always use your calculator. Then what can I do? You guys know how to solve equations using powers. Subtract 9 from both sides. A squared is equal to 216. If A squared is equal to 216, that's okay. But what I want to work out is what is A by itself? How can I get rid of that squared? How can I get rid of that square? I'm going to do the inverse. The inverse of squaring is square rooting. So I'm going to square root both sides, and the square root of 216 is about 14.7 feet to 1 decimal place. Okay? So please make sure, a lot of people leave their answer as 216. Why can't it be 216? It cannot be 216 feet for A, okay, because it has to be shorter than C. So 216, A cannot be 216 because it's not less than 15. Remember, the hypotenuse has to be the longest side. So you know when you reach that stage there that you have to square root it. And we can always double check our answer. Is 14.7 less than 15? Of course it is. Okay? So that means we're on the right track. If you found if your A to be bigger than the hypotenuse, then you made an error, and I recommend you to kind of double check what you've done. Okay? Finally, what I'd like you to do is read this question here and try and have a go. The diagram's already helped you out a bit. What I would like you to do is work out what is the maximum height that the top of the ladder can reach when used safely. So read the question, pause the video and have a go. All right, let's just quickly go through this. Let's read this question. A window cleaner wants to clean the upstairs windows of an office. To meet safety regulations, his 10-meter long ladder needs to be angled so that the bottom of the ladder is at least 2.6 meters away from the wall. What is the maximum height that the top of the ladder can reach when used safely? Give your answer to 1 decimal place. So this bit I've underlined is an important piece of information, 10 meters long ladder, and at least 2.6 meters away from the wall, another very important piece of information. What is the maximum height that the top ladder can reach when used safely? That tells us what to work out. We need to work out the maximum height, and then to 1 decimal place. So using our triangle, okay, the ladder needs to be angled. So you know the ladder is being leaned against the wall, okay? So if it's 10 meters long, it would have to be the longest side. It would have to be the diagonal side, okay? It can't be vertical. How can a ladder lean vertically? It would have to lean sort of diagonally against a wall. And then it's 2.6 meters away, so that's one of our shortest sides at bottom. And then if it says work out the maximum height, then you know the height can't be diagonal. Height would have to be, it's talking about the vertical height, okay? That is the maximum height. So what we're trying to work out is we're trying to work out what the shorter side is. Label the sides all together, A, B, and C. Use our formula. A squared is equal to, we're gonna use this one, C squared minus B squared. It's just the same one as before, but it's a quicker step actually. So all you do is you square the two whenever you're working out one of the shorter sides. Remember from the video Pythagoras 3, a quick tip is square the two values that you're given, subtract them from each other, and then square root the answer. So if I square, if I do 10 squared minus 2.6 squared, that gives me 100 minus 6.76, and that gives me 93.24. Okay. A lot of students leave their answer as this. They think A is equal to 93.24. And again, that cannot be right because it is much bigger than 10. And A cannot be bigger than the hypotenuse C. So what do I need to do to 93.24? Well, I'd have to square root it because A squared is equal to 93.24. If A squared is equal to 93.24, then A would be the square root of 93.24, and that gives me about 9.65686 recurring, and to one decimal place, that gives me 9.7 meters. Okay, and that's how